There's quite a few miles of cordage. I think it's somewhere about 31 miles of cordage in actual fact aboard these boats. That's the rigging, standing rigging, the running rigging, and below decks the gun springs were all cordage, and they were all made at Chatham. All the cordage for rigging the men of wars of the days of Trafalgar, and even when the Dutch were coming up the river to raid as well, most of the English men of war were rigged with cordage that was made at Chatham Ropery. The Victory obviously comes to mind because that was built at Chatham, and the original cordage was certainly made at Chatham. The main rope walk dates from 1720, and our main spinning room from 1785. These were supposedly built, the present buildings, by the French convicts and other convicts of the day. I started as an apprentice in here in March 1939. 2 12-hour shifts working at that time. 12 hours day shift, 12-hour night shift. 7 days and 5 nights I used to work right through the war. My wife worked in here during the war. Also, an aunt of mine worked in here, sister. In fact, most of the old rope makers married their wives from the Ropery spinning rooms in the old days. It's always been rather a family background to the place. One of the biggest problems we have is the fire risk in the building. Bearing in mind that it's wood throughout and it's a quarter mile long, totally open on each floor, and also the floors are impregnated with tar from the old tarring days. So the fire risk is very great. It doesn't occur today, but in the old days when I first came in, every employee that came into the Ropery had to enter by the main entrance. All other doors were locked and they were searched for any smoking material. Along the far end of the floor we can see one of the largest ropes we make is a 24-inch. That particular one is a cable-laid rope, which means that you've had 3 ropes of 3 strands cabled together to make a 9-stranded rope. These are mainly used for towing springs, one of which is placed between the tug and the wire and the towed vessel. The bowl coming up through the hatch from the hemp houses below, that is Manila from the Philippines. This particular lot is grade 1, which is being used for the abseiling and climbing ropes for the Royal Marines. Well, before the days of the hard fibre, which is used in the modern ropes, sisal and Manila, previously it was soft hemp. That was nearly always tarred in those days. But nowadays, since the 1418 war, when it became difficult to get hold of the hemp and also the price became prohibitive, we've changed over now to Manila from the Philippines and sisal from East Africa, the best of which comes from Tanzania. The Manila fibre tends to be longer than the sisal, which it needs cutting to the length so the hackling machine can cope with it. They're cut across a circular cutter, which you can see the women using at the moment. They're then placed on the tables ready for the spreader on the hackling machines that follow. It's strange, it's outside industry, possibly you find women and men intermingled, both in this side of it, the preparing and spinning, and also in the rope making side. But here this has been traditional, that ever since 1850s, the women then were the first women employed in the Admiralty service. They were usually widows of servicemen and police, or spinsters if necessary to get any more. And we've still got a relic of those days still left, in as much as that at that time the women, in fact the whole of the Ropery, used to start a quarter of an hour later than the rest of the dockyard, have a meal break which started a quarter of an hour earlier, and also they finished a quarter of an hour earlier in the evening. The idea of that was that they wouldn't have to mix with the common dockyardmen going in and out the gate. We still retain a relic of that, in as much as we've got a midday break of a half hour, which is a quarter to 12 to quarter past. We retain that jealously, that break, which is the only one in the dockyard. What you can see on the hackling machine at this stage is the last of a run of sisal, which is the, as I explained before, from East Africa. And this is being put through the first hackling stage, of which there are 3. Well, this hackling really is a rough combing. It goes through 2 sheets of pins, one which is travelling slow and a faster one which straightens the fibres. And also at that stage, there's the batching compound goes on, which contains a rock proofing as well, which put lubrication and also the rock proofing agent to keep the bacteria rot out of the finished product. So the sisal at this stage is loose fibre, about 3 foot in length. Now these short lengths have to be put onto the spread table, which we can see in front of us here now. They're laid on head and tail, top to tail. They're carried along the spread table through rollers and then onto very sharp pins, which in effect do the combing of the fibre to straighten it. And we've already said that the rock proofing and the batching compound goes on at this stage. Now when it's been over this system of pins, it's carried forward to delivery rollers, and from the delivery rollers it's delivering a continuous sliver. The short ends that go in at the front are now married together and become a continuous sliver, which is in the bale form, which you can see on the front of the machine at this stage. Well, the resultant bundles of sliver are approximately 100 weight to 100 weight and a half, and these are dragged across the floor by the women with just an iron hook placed underneath. From this machine, they're only actually going up into a further hackling machine, taken up over a system of rollers, which we can see overhead, and it goes through 3 of these stages in effect before it becomes ready to be dealt with by the bell frame, the first drawing frame. This is where the first control is obtained, because from the rough fibre which we've already seen in short lengths, we have to obtain a uniform thread which is the same weight per unit length. Well, the first machine on the drawing side is the bell frame, which delivers 350 yards and automatically cuts off. The resultant bundles are then weighed so that we can obtain a set. That set is then balanced up with 4 or 5 of these bundles to make up a set weight of 525 pounds, so that when they go through the second drawing frame, you've then got a uniform sliver, which is then becoming almost the spinner's fibre or sliver. The spinning machine, these are rather modern machines. When I first came in the Ropery in '39, they were then what were known as the old spinning jennies. But as you can see, this particular machine is very modern. It's got electrical cutouts. It automatically cut off when you get a set yardage. But the object of the machine here, you've got the sliver coming up the back of the machine, which we see going in to the cowlings. It goes over the top and carried through with pins and faller bars. And then the flyers in the front here, which we can see going round, are putting the twist into the thread and also winding it onto the bobbins, and the staging's going up and down to get a roving evenly over the bobbin. When the bobbins are full, the machine will automatically cut off. Then under air pressure, hydraulically, they will be lowered onto tables, brought forward, which brings the full bobbins outside of the machine, and an empty set of bobbins in the position ready to go up inside the flyer housings to start the next set again. And the resultant bobbins here are ready to go on the rope walk for the rope makers to make up into strands. You can see here that we've got the spinning stage of the job, the wrong end of the building, or we've got the machinery and the men's place the wrong way round. It is due to the fact that machinery came in rather haphazardly, and certain machines were replaced hand spinning and hand rope making, and they came in rather the wrong order possibly, but because we've got the problem of transporting these bobbins from one end of the building nearly a quarter of a mile to the far end for the rope makers to work on. This is one of the biggest problems because it's non-productive labour. But the bobbins which we saw spun are now being placed on the bobbin banks, which we can see in front of us now, and the rope maker is gathering the threads to reeve them through the register plate, and the object of the register plate is that it registers the formation of the strand. If he should reeve this up and too many on the outside and not enough in the centre, then you will get friction between thread and thread, which will weaken the breaking strain. If, on the other hand, you get too few on the outside and too many threads in the centre, bacteria rot can set up too easily in the finished cordage. So it's rather important that he gets the reeving up, which he's doing now through the register plate, in the correct order. Having done that, they're taken to the front of the frame. The resultant strand, roughly formed at this stage, is pulled through a very tight die to the size of the diameter of the strand that's required, and then placed on the forming machine, which will travel down the floor, taking the finished strands. Well, the conditions in the rope walk are rather different to the women's room where we've just come from. They have heating arrangements in the spinning rooms, but out in the rope walk here you can probably feel it yourself that it's rather cold, and during the winter months it's extremely cold. The temperature is very often below freezing point. If it's below freezing outside, it's also inside. While they had to control some rough elements when I first came in, there was a very rough crowd at that time. You had regular stand-up fights every day in the old days. It was, I would imagine it was something to relieve the boredom, which is something we've alleviated over the past 20-odd years by constantly rotating the workforce from one job to another, so they're not on the same job too often. At the far end, 1,128 feet away from us here, is a capstan on a rope drive that pulls the machine down the floor, and you will see the rope is going over a system of cogs. As the rope is pulled down the floor, it is pulling the machine down the floor, rotating the main drive wheel, which through the system of cogs is linked to the front hooks at the front, which imparts a twist at the same time as it's moving down the floor. So the capstan is doing two jobs. It's traversing down the floor with the machine, pulling these strands down, and also putting the twist in, which is required. The younger lad, he's steering the machine down the floor, and his mate is going down alongside of him, is placing the trestles underneath to keep the strands apart so that they don't lay on the floor and also get fouled and twisted together as they go down. When we get to the far end, we've got strands then which will make up, three of which will make up a rope. They're taking the three strands from the forming machine off the hooks and tying them around the post, preparatory for the layer to use to make cordage. The reason they laid there is to enable the strands to settle in their unnatural twist so that they're not taken too quickly onto the laying machine and put the next system of twists in too soon. Ideally, they should lay there for at least a day, but this is not always practical. That is the laying machine. Well, they're placing the wooden top in between the three strands. There's a hole in each side of the tops, which an arm bar is placed through, which is then put into the top cart, which we see in front of us here now, bolted in so that as the tops are pushed along the floor, they don't rotate and fly all over the place. And when you start the twist imparted by the machine, the twist forces the top cart, which takes the wooden tops, pushing it along the floor, and the grooves enable the strands to lay parallel with each other without crossing, so that they're true throughout. We can also see the rope maker putting further ropes round the three strands which have been twisted by this stage, and the object now, he has to take this along the floor. It's pushed along the floor with the force of the twist from the machine. He wraps these ropes around the newly made rope. It acts as a brake. Due to his skill, and this is entirely his skill. There's no motive power for this cart going along the floor other than the twist being put in. He controls the rate of progress along the floor to enable the finished cordage to be laid at an angle of 37 degrees, which is required. And we'd almost stake our reputation that any of the cordage we see here would not be more than half a degree out at any stage. I think this is one of the oldest trades ever. It dates back to the Pharaohs, at least, and the construction of cordage is not dramatically changed ever since those days. Certainly our own ropery that's left now that we've just been looking at and going through is probably the largest, and it's certainly the longest rope walk left anywhere in Europe at this particular time.